Let's start the training. Go live. Sunny, may post करा post Hi guys, so I just want to show you a little demonstration of kind of what I did pretty much yesterday, I guess. Um, so I wanted to build this sort of lightweight games engine. Well, there's a lot of games engines around, and I was kind of inspired by Andrew's swing game or splash kit, the way he call it. Um, the basic idea is it's kind of easy to teach introduction to programming with something very lightweight, and that kind of works cross platform. And that's kind of what I wanted out of this xfEngine. And I'll show you what I mean. So let me see if it's switching. Yeah, it's switched. So hope you can see this. So what xfEngine is essentially is just a web page. So what you get is just a empty web page, and then you get some JavaScript with libraries which I've written, and all of them being sort of rendered into the canvas of the HTML web browser. And there's ways of sort of porting this experience into the computer and desktop environment, and also mobile. We'll talk about that later on, but for now it'll be just on the web browser. And see how much dependencies sort of I'm using. It's just essentially HTML5, and that's it. And there's no any other dependencies. Although when I'm actually porting this experience into sort of a standalone experience, that would take some kind of a few of node dependencies, I guess. Anyways, so this is kind of the Sprite class I've written, but I'll get into this. So the way this kind of works is that all you have to do to get started on is just to import the relevant base classes you want. For now, I'm just going to be talking about Sprite. And if you go to the app.js, this is how it looks like for now. So if you've done Swing Game, this sort of looks familiar. As you can see, there's this game loop that happens down there, and so this function handles all the moves, handles all the inputs, and this function handles all the updates, and this function handles all the rendering. So the way this works is just you can actually create sprites. So I'm just going to showcase the sprite aspect of this library, which I was working yesterday. And so the only thing I have to do is to make a sprite. All I have to do is to define the sprite I want. So I'll be defining sprite equals new sprite. So at this point, the sprite is generated, and since I'm using inline definitions, I can actually say define the resource. So the resource I'm going to be using is this one. If I can get this, hold on. So I have this. No, not Mario. There you go. So I'm going to be using this kind of a meme that's going on right now. It's called Purple Bird. I don't know. So this image is a sort of a sprite sheet. So we have we have 4x4 image sprite sheet with 15 different sprite frames, I guess. So if you want to, so I'm gonna use. You could do like a one sprite thing on the app itself. So if you have just one sprite. If you have just one sprite, you can just specify this image like, so the image is going to be on, so if you look at the directory, it's going to be on the images, I think, I can't remember. Yeah, it's going to be assets for that. So all you have to do is just say assets and / the image you want, which is purple underscore bird .png. And see if that I'm using array notation here. It's essentially because you can actually have multiple layers of images drawn on top of each other, and that's kind of cool too. I'll show that off later on, but for now I'm just going to be using one sprite layer which has 15 frames. And all right, so that's the image resource, and you can actually have, so the way kind of this works is that you have to specify the image resource. I'll just get the template out of my copy. Out of my clipboard down here. So the way the template works is that, not the template, the class itself works is that you specify the name of the sort of the state the animation is on. So this is just for This is just for animated sprites. If it is as idle sprite, you just all you have to do is to take this off and take this bit off. But if it is an animated sprite, you'll have to specify which sort of name you give the keyword, and also the list, the array of layers, all the bitmap layers. And so these parameters are just saying that this is having two. Hold on, this is for the braid idle. So in this image, I have 1, 2, 3, 4. So altogether there's 4 rows and 4 columns. So if you look at down here, all I have to do is say 4 columns and 4 rows. And this is the number of frames you have. So if you look at this image again, it'll just be saying 14 frames altogether. So it'll be 14. Wait, hold on, 15. All right, and this is next parameter is going to be the starting frame number. So I want it to start from the first frame, but you can actually say whatever the frame you want. And the next parameter is just whether you want to whether you want it to loop or not. So that's it. And the good thing is that you can actually concatenate. You can actually define all the other attributes. So for example, you can say if I wanted to move or translate this sprite into a different position, I would have to say translate and say 50-50. So this is equivalent to draw at move in swing games, for example. And you can also say translate, and you can also transform this image into a different scale. For example, I can say transform into I think the image is 150. I'm not sure. You'll see it, and that transforms the image into different Yep, and also I can actually there's few more functionalities that goes with sprites. For example, you can say things like collide. You can actually find a bitmap layer that dictate how it collides with other sprites. And I've done some pixel level collision as well. Yep. Yep, I'm back. So you can actually define it to sort of collide on a specific layer of bitmap. By default, it just gets the first layer we defined down here. So hold on, and just changes to purple. Let's go bird. And yeah, by default, it's going to do this automatically. So I'm just not going to bother. And you can transform, and you can also you can actually give forces and accelerate velocities, stuff like that. I'm not going to go on to that, but for now, you can. This is all I'm going to do for now. And yeah, so that's the you define the sprite down there. Now, if you want to render the sprite, you would have to say sprite dot render, and you need to pass down the context to draw on, which is CC in this case, which is down then different there. Context is just the canvas itself. So if we refresh the page, you should see something happening. Oh, no, I guess not. So this idle. Oh yeah, it has to be animated sprite. I'm thinking of. Let me just get the define. Yeah, one more thing is that you need to actually define the. This is kind of a bug, I guess, for now, because you kind of need to define the the scale before translation, vice versa. I'm not sure, but no, you can fix that. It won't take that much time. And yeah, so let me see what's going on. Centers at translates at. So down here, I have yeah. So what I did was there you go. So you have the entire image itself. What I was doing wrong, I guess. Oh yeah, I wasn't updating, of course. Hold on, I don't have to draw it here. Do I? Oh, yeah, I do have to draw it. So it's an update loop calls draw and draw actually draws the image itself. So yeah, so what happens here is let me actually clear up what I was doing. So I've created the sprite, the animated sprite with the bitmap, and so the purple bird has the animation itself. And what I'm doing is on this on the mouse move, I'm pretty much setting the purple bird's position into the mouse position divided by its center. So I'm actually kind of trying to center this out. I don't know why it's not centering exactly, but anyways, again, and then I'm updating the bird's position there. So if you want the sprite itself animate, you need to actually update it. And for example, if I don't, that it'll look like that. And I can also sort of rotate the bitmap here too, just to showcase what I'm talking about earlier. You can say rotate by 0.1 radians. That would look like that. Yeah, and also you can actually specify other parameters. For example, you can say I can set up a velocity of given so this is the horizontal component and the vertical component, so it'll this is kind of fast away anyways. So you'll actually move slightly to the left or to the down. It's going down in this case. Let me see if it's working correctly. It's not working because I'm kind of clipping it onto my mouse. If I don't have my mouse enabled, it will look like it's going down. Yeah, it's going down. Anyways, you get what I'm saying. So you can actually specify velocities. We can do vector additions. You can have relative motions, stuff like that. Yeah, so that's the sprite. There's some collision text. I'm not going to show it off right now because there's some bugs, but it looks something like. Where's the? Let me grab that. So there's my collision sprite. There you go. This guy. Yep. And I'm gonna change the purple bird to Mario because that's more easier to see if it's colliding or not. Do we need to update Mario? Let's try updating Mario. Yeah, let's not have that bird running all the time, and I also need to render the sprite itself. See, that should yeah, there you go. Cool Mario. Oh yeah, this is something I need to showcase anyways. So the sprite has in this case this sprite is actually the Mario sprite I'm working with right now. You can see it's sort of clipped into the mouse right now, and you can see that it has two layers of Mario-ness, I guess. The Mario 1 and Mario 2. The Mario 1 is just the just one image, and this is not an animated sprite, by the way. So the Mario 1 is just that, and Mario 2 is just the shades. You could either define the collision masks to either one, but by default it goes to the first one. And I have already look into this sort of which is just a mask, and I'm translating the weight is just for the physics there. And yeah, I do have braid to let's render that and to showcase animate. I guess you have seen animated ones already, I guess. Yep, so that's braid dot update. Yeah, there you go, braid. So you can see if it's where's my spikes. So I'm just going to showcase the collision, I guess, right now. So this is my spike object. So here I'm just creating a spike object based on the event resource, which is spikes with the collision mask of spike C. I'll show these images right now. Spike C is just it's essentially the same image. I just toned it differently to see if it's different. So the spike is just that. And in the app, I'm just defining and translating and transforming the shape to the way I want it to be. And here I'm just gonna draw the shape down here. So the spike's gonna be rendered as well. the way the order you render these images is gonna if ultimately affect which one comes first and which one comes later. Why is that it's not rendering? I don't know. Do I have to update that too? I can't remember. I'm not sure if you don't need to update that. No, I don't. It crashed, guys. It did. Wait, hold on. Where is it? Spike to render. Spikes. Oh yeah, it's spikes. This is there you go. So the braid is kind of on top right now. Anyways, so you can actually let me show you how it's how the collision detection sort of works. The algorithm is kind of long, but I'm not gonna bother you with the algorithm itself. But I'm just gonna show you how it's implemented. So I'm gonna implement the sort of the thing I want to show you is the collision detection is just so you can see the collision detection is sort of pixel perfect. It kind of is yeah, it's pixel perfect. It doesn't kind of currently work with rotation, but it does work with scaling. So rotation is something I need to fix. I think original Swing Game had the problem too. Wait, I think Andrew fixed it later on somehow, I guess. But it initially had that problem. I remember Shri having a problem like that with his Rockets game, where the collision didn't work after rotating the bitmap or whatever. So yeah, I need to get. I kind of know what's wrong with the algorithm. I need to fix that up. So that's kind of it for now. Let's get the purple bird running. There you go. There it goes. So yeah, so you can see you can actually set up a sort of easy environment with just few lines of code, and sort of like made it easy to learn and easy to understand what's going on as well. And so if you're familiar with just Swing Games environment, let me get back to the way it was. Get the bubble bird, click to the mouse, and get the two guys get out of here. The two guys can get out of here. Okay. So we just have the purple bird. Okay, let's just get rid of the velocity. So yeah. So the idea is that you can set up this game environment quite easily without much of a hassle. So just to illustrate the point, all I'm doing is just importing my JavaScript classes, and in my app.js, which is the main JS, I'm just setting up the canvas and doing all that. And yeah, and the cool thing is also is that you can actually make this a standalone version, and that's kind of doing through Atomic, I think. Is it Electron, something like Electron. And so the way you set that up is by let me get my I did close that, dang it. So so if you do build.sh, something similar to Swing Game in this case, I guess, you can actually run Electron. I'm using Electron to sort of port it into this top version, I guess. And for this, which we need a node environment. Yeah, so I can just run .sh and it'll actually run the game on a standalone app. Hit the console, and there you go. And so the build assembly is sort of straightforward. I guess you don't actually have to worry a lot about the like the specific natures of each of the platforms. All you have to actually focus on is your engine and your game. So that's sort of what I'm focusing and aiming for. And yeah, I guess that's all that needs to be said. Yeah, also thanks for watching, and I'll see you in the next video.